So for today, we are going to continue on chapter 4, and the very first concept that we are going to cover is the concept of variables. So variables are very, very, very important features of ProModel, and they enable you to add a lot of flexibility to the models. They are very, 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 very important. So you guys have to learn those very well and be able to use them when you need to. So when we develop a model, we run it, and the output viewer generates a bunch of results for us, right? A bunch of statistics on so many things. However, there are also still a bunch of things that it doesn't calculate for us, and we are interested to know them. Variables help us to calculate the rest of the things that we want to know, but the simulation does not calculate for us automatically. Okay, so that's the importance of variable, and that's what they do for us. Now, I want to develop the first model. So in the first model, this is the structure of the model. I want you guys to create a folder for week 4, please. Okay, create a folder for week 4. Inside that, we are going to create a model. I'm going to call the model as SoCal Casting. You see on the top of my page, the name of the model. I'm going to call it SoCal Casting - Global Variables. This is the structure of the model. First, our entities come in, they go to the receiving dock. From there, they go to the mill machine. From there, they go to the grinder. And then from there, they go to finished parts store. Okay, so the entities that come to the systems are called castings. So casting comes to the system, they go to the receiving dock, then to the mill machine, then to the grinder, and then to the finished parts store. All these locations have capacity of 1 except receiving dock. Receiving dock has capacity of infinity. There is no limitation on how many parts can come to the system. They all come, they go to the receiving dock, and then from there, they go through the rest of the system one by one. Okay? So all the locations have capacity of 1 except receiving dock that has capacity of infinity. One more important piece of information that we know is that we receive castings in batches of 4 every 60 minutes. That's all we know. We receive castings in batches of 4 every 60 minutes. So what I want you guys to do is to create the locations. Obviously here we have 4 locations: receiving dock, mill, grinder, and finished parts store. Create the entity. We have 1 entity, casting. Create the arrival, given this important information that we know. We receive castings in batches of 4 every 60 minutes. I will call your name, guys, and I want you to tell me how you capture this part of information, how you capture the arrival process. And you can also finish the processes. Parts go from receiving dock to the mill machine, to the grinder, and to the finished parts store. So please finish this part. When we go to the processes, I give you the processing times as well. So as we talk, we have 4 locations: receiving dock, mill, grinder, and finished parts store. Everything has capacity of 1 except receiving dock that has capacity of infinity. Then we have 1 entity, casting, and then we have the arrival. So before we get into how I did the arrival, let me ask you guys this. How did you capture this? We receive castings in batches of 4 every 60 minutes. So what is quantity each?
4.
4.
Because?
Because it's batches of 4.
Every time 1 arrival happens, you get 4 castings.
Exactly. Every time 1 arrival, every time each arrival happens, we get 4 batch, 4 we get 1 batch of 4. So basically we get 4 castings together. So in each arrival, we get 4 castings together. They come together in the system. They go through the rest of the process one by one, but when the arrival happens, 4 of them come to the system one by one. So quantity each then should be 4. The number of entities that come to the system in each arrival. First time is 0. They can come to the system from the start of the simulation. What is, tell me, what is frequency, the inter-arrival time?
60 minutes.
Is it random or fixed?
Fixed.
Fixed.
Because?
It doesn't say average.
You don't
Or-
see the keyword average. Okay, so it's fixed 60 minutes. And tell me what is occurrence?
It's infinite because we keep getting batches until the simulation ends.
Exactly. There's no, this sentence here doesn't tell you how many batches we are going to get or anything on that sort. So the occurrence is infinity, meaning that for as long as we want to run the simulation, these batches of 4 will come to the system, and that's perfectly fine. Okay. Okay, so that's arrival. Okay, that's great, guys. So casting goes to the receiving dock in batches of four castings arrive to the system at a time from the start of the simulation. Every 60 minutes, that's inter-arrival time. And this can continue for as long as we run the simulation. There is no limit on number of castings or number of batches that can come to the system. Okay, so that's your arrival. And then we are going to go into the processing. So processing, as I said, we go from receiving dock to the mill machine. We go from the mill machine to the grinder. The processing time at the mill machine has normal distribution, average 3, standard deviation 1. And then from grinder, we go to the finished part store. At grinder, the processing time is uniformly distributed with average 5 and half width 1. Okay, so uniformly distributed with average 5 and half width 1. And then from finished part store, they go to exit. So a couple of questions for you guys. Okay, so the processing is simple. We know exactly where they go, the route they go through, which location to which location, and so forth. We also know the processing time at the mill and at grinder. There's no processing time at receiving dock or finished part store, so we are good. For the processing time at grinder, obviously it has uniform distribution. So I could give you the information in another way instead of just saying uniform with average 5 and half width 1. So can you tell me this means that the processing time at grinder varies between what and what? What is the minimum? What is the maximum?
4 and 6.
Minimum is 4, maximum is 6. 5 is the average. Average minus half width gives you the minimum. Average plus half width gives you the maximum. So 5 minus 1, 4 gives you the minimum. 5 plus 1, 6 give you the maximum. Okay, so I could tell you that processing time at grinder has uniform distribution and varies between 4 and 6. Or I just could give you this information that processing time at grinder has uniform distribution with average 5 and half width 1. In both scenarios, you had to write the processing time at grinder like what we have here. Okay, so make sure you guys are comfortable in terms of how do you get the information and how you have to write it in ProModel. Okay. One more piece of information that I want to give you here is that there is 1 minute move time between all these locations. Okay, so it's not that when the part is done at mill, it can immediately get to the grinder. There is 1 minute move time at these between these locations. Can you tell me how do you write that part of the code, and where are you going to write it?
You write it where it says move logic.
We write it in the move logic. Can you tell me how you write it?
Move for 1 minute.
Move for 1 minute. Okay, so I want you guys to do that as well. So for all the movements or all the transitions that happen from one location to another, I want you to also add the transfer time, which is 1 minute. We are not using any resource or anything for doing the transfer. We just want to simply capture the movement time, which is simply 1 minute. Is it fixed or random?
Fixed.
Fixed.
It's fixed. If it was random, I would write the distribution like normal, exponential, uniform, whatever it is, but I haven't done that, so it's fixed. And I put the move time, as I said, for all the locations. So I put the move time for all the lines except which one?
Your finished part store, your last line.
except the ones when the part goes to exit, because that's something that happens in the simulation where it doesn't correspond to a physical transport or physical action in the real world. So I don't need to put any move time for the last line where I go to the exit. I don't need to worry about that. But for every other line, make sure to add the move time, move for 1 minute. Okay. Okay, about 400. So in the location for the receiving dock, there's no queuing rule. So pay attention to that as well, guys. There's no queuing rule for the receiving dock when a bunch of parts come in. They're just get there, and any one of them can be the next entity that goes through the process. We ran the simulation for 100 hours, and we, as you remember in the arrival, these parts arrive, or the arrivals happens every 1 hour, every 60 minutes. So can you tell me why I have 400 exits?
Because 4 units arrive at a time.
Exactly, because
We're
these
counting, not units.
exactly the arrivals happens in batch. So I get a batch of 4 in every 1 hour. So in 100 hours, basically I get 400 parts, and it just happens that I can process everything within that time. So I also get 400 exits during the 100 hours of simulation. And as you have seen so far, simulation automatically calculates a bunch of things. If you want to see summary of the entities, if you want to see summary of the locations and utilizations and so forth. However, there are still a bunch of other things that you want to know or are important to know, but simulation does not calculate them for you automatically. And with the help of variables, you can do the calculations in the model. The only thing you need to know is to how those things are calculated. If you know how they are calculated, you can just write the code in the processes and get the things that you want calculated. One of the things I want to calculate here is work in process. Can someone tell me what is work in process?
WIP is all the material, the sum of all the processes that are in process and haven't finished with respect to your part.
So basically the number of all the parts that are being processed. They're somewhere in the process, but they are not done yet. You're right. So they are either in the mill or the grinder or waiting in the receiving dock, or they're in finished part store. If we had queue here in between the machines, they could be waiting in the queue. They're somewhere in your process, but they are not done yet. And also, please, someone tell me why it's important to know your WIP, why it's important to care about it.
Because if you have a high WIP, you probably have a bottleneck somewhere. Your process
Exactly.
is inefficient.
That is correct. The WIP, those parts in process basically are your potential revenue, right? You want to get them done, send them out, and make money. If they're sitting somewhere in your process, that means there's a bottleneck, there is a queue somewhere, there is something wrong in your system that doesn't let these parts to be done and leave the system sooner than later. So that's one of the performance metrics that every manager wants to monitor. And if they are going up over time, that means something is wrong with the process. So that's one of the important indicators that you want to be able to calculate for any production process. So, however, that is not something the simulation automatically calculates for us. We cannot get something like that from the output viewer. Okay. However, we want to be able to calculate that ourselves. So now I want you guys to tell me, forget about the simulation. Imagine you had just one piece of paper and a pencil, and you were in this manufacturing facility. What would you do to calculate work in process? How would you calculate work in process? Forget about simulation. Tell me, I want to find the logic of calculation of work in process. Okay, let me tell you then, what do I mean by how we want work in process to be calculated. That may help us in terms of what do we want. Let's say I'm just going to start looking at the process at some point in time. Okay, I don't care. It's not necessarily a start of the process. At some point in time, I look at this manufacturing process and I count how many parts are somewhere in the system, sitting somewhere in the system, being processed, or they wait to be processed. And I see that is 5. And then at some point, a new part comes to the system. No part has still left the system. They are still there, but a new part comes to the system. So then the number of parts that are still somewhere in the system goes to 6. And at some point, again, the time goes by, at some point, again, another new part comes to the system. And let's assume no part still has finished and has not left the system yet. So the new part has come in. So the number of parts in the system goes to 7. And then time passes a little bit. Then one of the parts is done and is leaving the system. So, and no part has come in, no new part has come in. Out of these 7 parts that are in the system, one of them is done finally and is leaving the system. And so again, the number of parts in the system, work in process, goes down to 6. And let's assume, again, time passes, no new part has come in. One of the parts again finishes and leaves the system. So number of parts in the system goes down to 5. And let's assume time passes. Let's assume no new part has come in. The number of one of the parts in the system is done and is leaving the system. Number of parts in the system goes to 4. Time passes, a new part comes in. No part has left the system yet, a new part comes in. So number of parts in the system goes to 5, okay? So if I wanna know work in process or number of parts in the system during the simulation time, these are the possible values for number of parts in the system: 5, 6, 7, 6, 5, 4, 5. And these values are going to be calculated as we go through the simulation, as the simulation time passes. These are the values that are recorded in the simulation. And at the end of the day, when I ask you what is work in process, you calculate average of these numbers. You calculate average of all the possible number of items that have been in the system at some point during simulation time. And what you are going to report to me is the average of these numbers as work in process in this system. You are also going to report the maximum. It's good also to know the maximum, to know that, yes, this is the average, but at some point there has been 20 parts sitting in your system. Be careful about that. It's important for you guys to know what this work in process is and how it is calculated. So work in process is average of number of parts that have been sitting in your system throughout the simulation time over time. And these numbers are just going up and down by 1 or 4 or whatever every time new items come to your system, or every time these items are done and leave your system. Okay, so that's how work in process is calculated. Now you have one piece of paper and one pen, and basically you are going to get these numbers for the production process. And at the end of the day, let's say you just want to report the work in process for the day. After 8 hours, you want to report average of these numbers. So if you wanted to collect these numbers, what would you do? How would you come up with the numbers of items that have been sitting in your system throughout the day so that at the end of the day, you can calculate their average? What would you do? What if I just I just stand by the door. Every time a new part comes to the system, I record it. Okay, every time a new part comes to the system, I increase the work in process by 1. And every time a part is leaving the system, I decrease the work in process by 1. Do you think that would give me these values over time? Every time a new part comes to the system, I just increase work in process by 1. I would say, okay, now it's 6. Now a new part comes. Okay, now it's 7. Oh, now a part's left. Now I go back to 6. Another part left. Go back to 5. Another part. Go back to 4. Now a new part came in. Go back to 5. So do you think that would take care of everything? If I had the way to just stand by the door, every time a new part comes in, increase work in process by 1. Every time a part leaves the system, decrease the work in process by 1. If I do that, do you think then I would be able to record all the possible values for work in process throughout the simulation time?
Yeah.
Okay. So if that's the case, if that's the logic that you would do to be able to get it to record what are the possible values for work in process over the simulation time, and at the end report their average. Okay, perfect. That we want to implement the same logic inside the processes, the exact same logic. So I want to calculate a so-called variable. Okay, so variable is something that you define And like any coding language, you can assign values to the variable, and it keeps the value that you give to it till you change that value for you. Okay, so I want to define a variable. I'm going to call this variable work in process. And I want to be able to increase this variable by 1 every time a new part comes to the receiving dock. And I want to decrease this variable by 1 every time a part leaves the leaves the finished part store. Okay, so let's do that. So to be able to do that, we have to define the variable first. And here you see on the top, there is an option for variables. Okay, so click on that. For those of you who are using 2016 version, you can go to the build menu and you see the variables over there. Click on that, you can define the variables over there. So go to the variables, and here I want to define, give a name to the variable. So define a variable. So here I'm going to call it WIP, work in process. Okay, that's the variable that I want to define to calculate work in process for me. And when you press enter, the rest of the line is filled automatically for you. If you double click on the type or just click on the type, you see here there are a bunch of options in terms of deleting the variable or moving it or so forth. But there are two important ones where you specify what is the type of this variable. Is it integer or it's real? Do you just see the integer values? Do you just put integer values in this variable, or do you put real values like the decimal points and so forth? So I pick integer because this working process looks at number of parts in the system. It goes up and down by 1. So it never, at the end I report their average, and that has decimal point, but the value that working process gets is all integer. Okay, so define that variable here. And if you have done that, let's go to the processes. Okay, so here, what do I want to do? At the start, when the parts come to the receiving dock, I want to increase the working process by 1. Okay, so, and if also you guys click on the operation, see the operation window opens, you can either write your code here or just write it here in the operation window. So I'm going to write it in the window here. It doesn't matter, both of them are fine, guys. At receiving dock, when the parts come to the system, I want to be able to increase the valuable working process by 1. So I say, okay, working process. And as you see, as soon as I start typing, the list of variables are shown here. And like always, pick the name from the list as opposed to retyping. Right now, working process is easy. You can just type it. But if you give a long name to your variable, always pick it from the list. Otherwise, you type it yourself and it creates typos and a bunch of things. So you might get error. So variable working process, whatever value is in it, just add it by 1 and save it in the same variable. Okay, so working process equals to working process plus 1. The initial value is always 0, always. So I said, when a part comes to the system, just increase it by 1 and save it in the same variable. So that's what happens here. And also the other thing is that I also want to decrease this variable by 1 every time a part leaves the system. So where do you think I should go to decrease this variable by 1 every time a part leaves the system?
Your last line of processes?
The last line. When the part is done at, that's where I want to go and say, okay, now whatever working process variable is in it, just deduct 1 from it and save it in the same variable. Okay, and that's exactly what happens here. So let's say if the value of the working process is 5, I say, okay, deduct 1 from it, go to 4 and save it in the same variable. So now the value of the working process goes back to 4. Okay, so that's basically what happens. So we increase it by 1, save it in the same variable. When a part comes to the system, we decrease it by 1, save it in the same variable when a part leaves the system. So that's what's happening with this variable. So when we run the simulation, the value of this variable goes ups and downs, depending on parts that comes to the system and parts that leaves the system. And at the end, simulation reports a bunch of things related to this variable. And let's run it. Now, if you want to see the value of the variable and some statistics related to the variable, we can go to the table again. Now, you see variable summary. That's where we go. We see the summary of all the variables we have calculated in the model, variable summary. Okay. There are a bunch of things here, guys. It's very, very, very important for you guys to learn which of the columns makes more sense and which of them actually do not make much sense, and you shouldn't report them at all. And also pay attention that some columns that may make sense for one type of variables may not make sense for another type of variables. We go through them and we learn all of them, but I want you guys to be mindful about this. For work in process, which one of these columns you think at the end of the day is a good one to report? So tell me the top one. Which one do you think is the best one to report?
Average value.
Because?
It gives the amount of work in progress at almost any given time, roughly.
Exactly. So the average, because that average is average of all these numbers that simulation keeps track of during the simulation time. So for work in process variable that we define, it's going to get these values as an example. This is just an example, but it's going to get this type of values during the simulation time. And at the end, if someone tells you what is the working process in this manufacturing process, you don't report just one of these numbers, or it's 6 or 7 or 4 or 5. No, you want to look at the average of all possible number of items that have been sitting in this manufacturing process at some point during the simulation time, and then give that number as the working process. So this average is the average of all those possible numbers. So that's the one that you want to be able to report. That's good. Tell me also, what would be another column that potentially has some valuable information?
Maximum.
Yeah. So I would say maximum also would be one. So which says that, yeah, on average there's one part sitting somewhere in your process. However, at some point there has been 4 parts sitting somewhere in the process. So, okay, keep that in mind as well. For some service industry, for example, for a bank, for a barber shop and things, these values may be helpful because working process for a barber shop or for a bank shows number of customers that are in the system. They're either waiting in the line or they are with the barber or with an agent. There are a number of people that are waiting in your system. So if I see the maximum in a bank is 20, okay, I want to make sure I have a space for 20 people. So knowing the maximum possible value for the working process is helpful. Sometimes it gives you a sense of how crowded your bank or your system can be. If you are thinking about how big of a bank I need, those can help you with those decisions. What does current value mean?
How many there's still in the system after the 100 hours?
Yeah, current value when we stop the simulation after 100 hours, how many parts are in the system? It's good to know, but I don't see any value in this because that's anyway, it's the value of working process at just one point in the simulation. Yeah, it's calculated, but I don't see much value in it. Okay. Minimum value. Okay, the minimum at some point there has been no part in the system. Okay, good to know. Total changes. What do you think this number is?
How many times a number has been added to WIP and how many times a number has been subtracted from WIP?
Exactly, number of times that this variable has changed. Either we have added one to it or we have deducted one from it. Is that value, and this has no meaning whatsoever. So absolutely meaningless for working process. I don't need to report these numbers ever. I don't need to worry about it ever. Okay, so that's one column you would never want to report for working process. How about average time per change? Okay, the time between these changes, when we change the value of the variable going up or down, what would be the time between these changes? So, and again, this not very informative compared to other values that we can get from the simulation. So then for working process, I would say the first two columns are not informative basically at all. However, the other, and the current value also is the last value that this variable took, okay. So I wouldn't look at the current value as well, but definitely average value is the most important number that you want to report related to work in process, and then maximum value, and then minimum. Okay, minimum is always zero, especially if you start with zero entity in the system, it's always zero because at some point there has been no entity in the system. So these would be important columns. And as I said before many times, guys, it's important to know this because you develop the best model on the board, but if you don't know what to report and where to get that number and so forth, still you don't get the maximum value out of those skills. It's important to know that for working process, which one of these columns are the ones that you want to report and make decisions based on those numbers. So what I want you guys to do is to define a variable, a new variable, that is going to calculate total number of parts that have been processed and have left the system. Okay, so total number of parts that have finished the process and have left the system. And that's something that simulation automatically calculates for you. Your total exit is basically that number of parts that have left the system, that have exited the system. I know this number, but I want you to calculate that using the variables as well. If you were in this manufacturing process, how would you, and you had just a piece of paper and a pencil, how would you record number of items that are done and have left the system at the end of the 100 hours of simulation?
I would be at the end of the simulation or the end of the process and count with my piece of paper and pencil, stand there at the end and see how many are leaving.
Okay, so you would basically stand somewhere at the end of the process, and every time a new part leaves the system, it's done and is leaving the system, you're just going to increase the value of your counter, right? Okay, so we do the exact same thing here. I define a new variable. I go to variables, define a new variable. You can call it anything. I'm going to call it total quantity. Is this variable an integer? It's going to get integer values or real values?
Integer values?
Integer values.
Because every time a part is leaving the system, it's going to increase by 1. So it's all integer values. Then I come to processing. So when is the best place to increase the value of this variable then?
Finished part store.
At the finished part store. I'm going to increase it by 1. So can you tell me what is the comment for writing that line? Total quantity equals to total quantity plus 1. Oops. Plus 1. Okay. So write in the last line, when the part is done at finished part store and is ready to go to exit, then I'm going to increase the value of this variable by 1. That's what I'm going to do. Am I going to decrease the value of this variable anywhere in the simulation? Do I need to do that?
No.
No, because this just wants to count number of parts that are done and are leaving the process. So it just needs to be increased by 1. I don't need to decrease it ever. And yeah, that's the best place that I'm going to do. So let's run the simulation. Where should I go to see the information related to this variable?
Tables, variable summary.
Variable summary. Yeah. So total quantity is the variable that I define. Now, this is my question. Remember we said for different variables, depending on how they are calculated, some columns make sense and some of them do not make sense. You know how the working process is calculated, the nature of the number that we see in that variable, and you know how the total quantity was calculated. Tell me for total quantity, which column is the one that makes the most sense?
Total changes.
Current value.
Which value?
Maximum value.
Maximum value, I would say. Total quantity is the variable that is increased by 1 every time a new part is leaving the system. So that's the number that is going up by 1 throughout the simulation. And at any point of the time that I stop the simulation, the value of that variable shows how many parts have left the system by that time. So the maximum value that I see for that variable at any point of time during the simulation is the value of at the last time where I stop the simulation, and that's the one that I want to report. Yeah, current value is the same, but I would never ever report current value. If these numbers make sense, we can definitely find them in other meaningful columns. So always ignore the current value column. So max value is the one that definitely makes sense. Minimum shows 0 because obviously initially no part had left the system. So this variable started from 0 and it went up by 1 as parts were done and left the system. Tell me, how about average value? Does that number make sense?
No.
Not really.
I would say no. Because this shows the average of all these possible values. So the total quantity has started from 0, has gone up by 1 every time a part has left the system. So if you look at the possible values for a total quantity variable, it's 0, 1, 2, 3, 4, 5, all the way to 400. And this number is just the average of those. I mean, meaningless for this variable. I know this variable has taken all the possible values all the way from 0 to 400, and this is just the average of those. I don't need to know. It doesn't mean anything. And yeah, so then for this variable, then the average value becomes suddenly the most meaningless things you can potentially report, while for work in process, the average was the most meaningful thing that you had to report. Okay, so be careful, be mindful about those. And that's why I explained to you how work in process is calculated, how total quantity is calculated. Be mindful about the definition of those variables, how they are calculated, because that helps you to find out which one of these columns makes sense to report, which one of them are absolutely meaningless to report. The total change, obviously, every time this variable has changed, and here is increased by 1, we record that, and that's the total change. Total change, again, never ever report anything in the total change column. If this number makes sense, you can find it from somewhere else in these meaningful columns. Okay, total change, never ever look at it for any variable. Average time per change, not much meaningful unless there is a specific circumstance. Okay, but never use this column. And the current value also, it's not a useful piece of information. And as I said, the values of this column, if they are helpful, you can always find them in other meaningful columns. Okay, so be mindful about which columns to report and so forth. Okay, so that's total quantity. Any questions so far?
Yes, I have one question.
Go ahead.
Can you just explain why the +1? I'm just a little bit confused of the +1 at the end of the total quantity.
Which +1?
So when you're writing for the variable.
Oh, here?
Yeah, like I'm just confused. Why did we have like +1?
Okay, so I want to calculate total quantity, and total quantity, when I stop the simulation, I want this variable to show me number of parts that have been processed and have left the system by that time. Okay, so in the very last line, I define a variable. The initial value of this variable is 0. At any point of time, when an entity starts from the first line, goes all the way to the last line, when I get to the last line and simulation runs this part of the code, when the entity is done and is leaving the system exit, the simulation runs this line of the code and get the value of total quantity, which is initially 0, add 1 to it, then it's become 1, then save it in total quantity is 1. Okay, now the second entity comes to the system. The second entity goes through everything, goes through the last line and wants to leave the system. Then the total quantity value is 1. It's going to be increased by 1, 2. It's going to be saved in the total quantity variable as 2 because 2 entities have left the system by then. So the total quantity, which shows the number of parts that are done and have left the system, now is 2. Does that make sense?
Yes, makes sense. Thank you.
Sure. And okay, one more piece of information, guys. You can write this line another way as well. There's another way for increasing a variable or decreasing the value. I'm going to write it here. You don't have to have both of them, just one of them is fine, but I'm just going to write it for the sake of learning. So if I want to decrease the value of a variable by 1, I can say DEC, which is abbreviation for decrease, and then the name of the variable, work in process. So decrease work in process is going to do the exact same thing that I wrote here on the top. It's going to decrease the value of work in process by 1 and save it in the same variable. If I want to increase a variable by 1, I say INC, which is abbreviation for increase. And then I'm going to put the name of the variable, whatever the name of the variable is. So increase total quantity is going to do exact same thing that I wrote here on the top. It's going to increase the value of the variable by 1 and save it in the same variable. So you can write any one of these methods that you like. Obviously, not both of them. Any one of them is fine. So either you can say value variable of x plus 1, save it in variable x, or you can say increase x, or you can say x minus 1, save it in x, or you can just say decrease x. Okay. So any one of them is fine, either increase or decrease, or just explicitly add 1 to them, save it in the same variable, or deduct 1 from them, save it in the same variable. Okay, any one of them is fine. One more thing is that always remember we talk about the compile option. Always, always, always use it. When you write a couple of lines of the code, just press it, compile successfully, perfect, no error so far. It helps you to catch the errors sooner than later in your model, and that's very helpful.
Thank you.
Professor, I had a question.
Yeah.
On that increase and decrease, it only works by 1. Is there any way to set it if we need it by increase by more?
Here you can say the number. So if I say, do you see, say decrease, the name, and then comma, the number. Here you can write down the numbers. If you want to decrease it by 4 every time, you can write it here. If you don't write anything, it's going to decrease by 1 or increase by 1. But you see here, you can write the code, the number here at the end.
Okay, thank you.
If you want to decrease it by 4 or increase it by, I don't know, 5 every time and things like that, you can do that. One more important information, guys, is that always also pay attention to the order of these operations or lines of code that you put here. So, okay, let me ask you this. I want to count how many parts have finished the milling operation. Okay, do this for me. Define a variable that is going to count how many parts have finished the milling operation for me during that 100 hours of simulation. So when I stop the simulation after 400 hours, I want the value of that variable to tell me how many parts have finished the milling operation. Okay, I created a new variable. I call it finished milling, and I go to the processing, and where do you think I have to go to add the code that helps me to count number of parts that have finished the milling operation during the time that I run the simulation?
Second line.
Second line, okay. And okay, so I'm going to increase it by 1. So when a part is done at the milling operation and the part wants to go to the grinder, that's where I'm going to increase the value of this variable, because that shows that this part is done milling. So, and it's good to go to the next operation. So if I want to count how many parts have finished milling, so I can write it here. So I'm going to write it with the increase method. So increase finish milling. So again, I just type F, the name of the variable appears. I'm going to pick it from the list. I'm not going to try to type it. You make mistakes, you get typos, errors, and so forth. Pick it from the list, okay? So now, my question is that, would it matter if I write it this way? So one is what you see on the top. Let's see, okay, and the other one is what you see on the bottom, as if I had written this line of the code this way. Is there a difference between these two ways of writing code? So either I would write it this way in this order, and I run the simulation and I report the results, or I write these two lines of the code in this order, I run the simulation and I report the results. Think about it for 30 seconds or 10 seconds, and then tell me if there is a difference between these two. Okay, so in the first time, we let the part to finish the processing. Part is finished and is really ready to go to the grinder. Then I am going to increase the number of variables. Then I'm going to increase this variable by 1, counting number of parts that have finished milling. But here in the second method, first I'm going to increase the part that tells me, oh, number of parts that have finished milling by 1, and then the part goes into getting processed. Okay, so then if I stop the simulation at any point of time, okay, let's assume I stop the simulation at the point that the part is in the middle of the thing. Okay, we run the simulation for 100 hours, 50 hours, whatever, right? At those times, there are a bunch of parts that are in the middle of the process, right? Let's assume I stop the simulation at the point that the part is in the middle of the milling operation, okay? In this scenario, I stop the simulation right when the simulation is somewhere at this line. The part is in the middle of the milling operation. Have I increased this variable by 1?
Not yet.
Not yet. Okay. And is that a good thing?
Yes.
Yes, because at the end when I stop the simulation, if I want to count number of parts that have finished the milling operation, and this part is in the middle of the milling operation, then I should not count it as one that has finished milling and has gone to the grinder, right? So that scenario, this order is good. The part is in the middle of the milling operation. I stop the simulation right here. Then I haven't increased the number of parts that have finished the milling for no reason, just because the part hasn't finished the milling yet. It's in the middle of the milling. However, if I follow this order, I increase the variable by 1, and then the part is in the middle of the milling, and I stop the simulation. So the part hasn't finished the milling operation and hasn't gone to the grinder yet, but I already have increased a variable that counts number of parts that have been processed. So the variable that I'm going to report to my team or to my boss or whatever is wrong. It overestimates number of parts that have been processed because this part is in the middle of the process, but I already have increased this variable by 1, and that's wrong. So pay attention to the order of the lines of codes that you write here. They do make sense, and there is nothing tricky about it. Just use your logic, simple intuition. The part should finish the process, then I can increase the value of the variable. I cannot increase the value of the variable if the part has not started even the operation yet, okay? So the second way of writing this is absolutely wrong. So when you write the lines of the code, pay attention to the orders that they happen in the real world and implement the same logic here. That, and one more thing I want to mention here is that you can also show the value of the variables here in the layout just for the if you like, and as you run the simulation, those you can just see how the value of the variables are changing. If you want to do that, let's go to the variable and then click on the variable, and then if you click here anywhere in the layout, this window appears. Okay, and then the same. And you see here the icon, which previously was no, now it's changed to yes. Now let's click on the total quantity and then click here. And then for the finished good, I already have done that. It's here, so I'm going to just go and move it around. Okay. And then if also you want to put a label next to them so which variable shows what, I go to the insert, click on the text box, click, and then write down the name of the label and put them next to the box. So this is okay. If you guys are done, let's run the simulation again. You see how the value of these variables are changing. Work in process, do you see it goes 0, 2, 3, 4, like it's up and down all over the place. For total quantity, it's increased by 1, like it just increases every time a new part leaves the system. And then for the finished milling, also the same. It just increases every time a part is done with the milling operation.
Is there a way to delete text box?
Yeah. Yeah, so I think wherever you are, just click on the text box and then right click and then edit background graphic. And then you have the option to delete them or change them. Okay, guys, we are good. Okay, let me see if I want to add anything else.
I had a question, Professor.
Go ahead.
Is there for the, you know how we calculated the number of parts that came out of the milling station that were milled?
Mm-hmm.
Can we put that same line and under the grinder processing, but before the weight?
Very good question. You can. So you see here for the mill, we said we are done at the milling. Now we are going to finish to increase the value of the variable by 1 that counts how many parts have finished the milling operation. And now he's asking, what if I come to the grinder and before I get into the grinder, then I increase that variable? Okay, so logically it's just the same. You are done with the milling, you haven't started the grinding yet, you are going to increase the value of the variable, okay? So generally it is correct. However, pay attention that here we have a move logic. We have 1 minute of moving between mill and grinder, okay? If I write it here, okay, let's assume I write it here before grinder. The part is done at the milling, and then it's in the middle of this 1 minute move to get to the grinder, and then I stop the simulation. What happens then? Would that
Probably get a least value than what we're supposed to get?
Exactly. The part is done at the milling operation. I'm supposed to increase the value of this variable by 1, but I have said, okay, I'm going to do it when the part gets to the grinder, and before I start the grinder, I'm going to increase the value of this variable by 1, and that's perfect. But that works for scenarios when you don't have any move time. If you have a move time between the milling and grinder, and then if you stop the simulation right in the middle of the move time, then you will face a scenario when the part has finished the milling operation, but you have not increased the value of this variable yet. And then the value of the variable that you report under reports, how many parts have finished the milling. Pay attention to these logics. And as you can see, there is nothing tricky about it. It's just the logic of the operation. Just think intuitively and logically about how the process is done. What if I stop the simulation at this point? Is the value of this variable giving me the right number, or is it over-reporting or under-reporting and things like that? And then that helps you to see where is the right place to put the value of those variables, increase or decrease and so forth. You can also increase or decrease the value of the variables in the move logic as well. Those lines of code can be written here as well. And again, for those, it's important to put them before the move operation, before the move time, or after the move time, and where is the right place to increase or decrease the value of those variables. Those are all possible as well. But as I said, just be mindful as what is the right place to increase or decrease the value of the variables. But all of them are possible.